Good morning, 7th grade. It's Monday, April 13th, and I hope you enjoyed your 3-day weekend with your family. It was so nice to have Friday off, wasn't it? Well, we're starting week 3 of online learning. So let's go ahead and dive in. We're on lesson 98, scale and scale factor. Now, if you've ever built a model of an airplane or a car or anything, you'll really have experienced scale factor before, because what you're doing with a model is you're creating a miniature version of something in real life. And that miniature version has all the same proportions that a normal actual life item would have. So when we talk about, one example of scale is if you have a blueprint for a house. If you're building a house, there's a blueprint. It's a piece of large paper, usually multiple pages, that gives you a picture of the layout of a home. And it is proportional to the layout of the actual size home you're going to build. And so let's say we have a blueprint, and it says on that blueprint that the scale is 1 to 24. That means perhaps maybe 1 inch on the drawing and the blueprint might represent 1 foot of a room in real life. So let's decide what we're going to do here with this situation. We have the length of a wall on the blueprint itself is 6 inches. And so you're looking at the blueprint and you measure, and the length of one wall is 6 inches. Now you want to figure out, what is the length of that wall going to be in real life? And we want to go ahead and find that in feet. So let's go ahead and make a proportion. So our scale is 1 to 24. So my first fraction will be 1 over 24. 1 representing the length of the drawing, 24 representing the length of the actual wall itself. And so in other words, 1 inch on the drawing will equal 24 inches on the length of the real wall. So if we know that 1 inch on the drawing is the same thing as 24 inches in real life on the actual wall, let's go now and see what would 6 inches represent on for the actual length of the wall. So I'm just going to make a proportion. 1 over 24 equals 6 over x. Remember, you have to have your drawing values both in the numerator to be consistent. Drawing is to actual length as drawing is to actual length. Now, we could cross multiply, but in this case, it's super easy to multiply across here. Instead of cross multiply, I'm going to multiply across. So I've got 1 times 6 is 6. And so if I just multiply 24 times 6, I'm going to have my answer. But this is in inches, 6 inches. And so this value will be with inches, and we're going to have to convert that to feet. So let's go ahead and multiply 24 times 6. And 6 times 4 is 24. 6 times 2 is 12. 144. So 6 inches on the blueprint represents 144 inches on the real wall, the length of the real wall. So now let's convert that to feet. Let's convert that to feet. Now I'm going to go ahead and use a unit multiplier. I'm going to put inches down below. I'm going to put feet on the top. I'm just going to make that over 1. And we know there are 12 inches in 1 foot. So my inches will cancel out. And 144 divided by 12, well, you know what that is. It's 12. And so I have 12. My remaining units is feet. And so the length of that wall in real life that I'm going to build or have somebody build for me is 12 feet long. But on the blueprint, it was actually 6 inches. So 6 inches on the blueprint represents 144 inches in real life, 24 times the length on the blueprint, and then we converted that to feet using a unit multiplier. Okay, now that is called scale. We use that with models and things. Oh, you know what? Let me pull this down. I need to pull that down so we don't have as much glare there. One of my windows. Okay, now let's go ahead over here and let's talk about scale factor. Now this can be a little bit tricky for students. It's really not bad if you think of it as a factor, okay? Factors are things we multiply. Let's start with something simple. I have a square that is, let's say it's 1 inch by 1 inch, okay? Now, I have another square that is 2 inches by 2 inches. And so what I'm going to ask is, what is the scale factor? In other words, what am I going to factor? What am I going to multiply the small square by to get the large square dimensions? And 1 times 2 gives me 2. Alrighty? So my scale factor, what do I multiply the smaller square by to get the value on the larger square? 1 times 2 is 2. And so my scale factor is simply 2. That's it. Now, if I were asking you what's the scale factor from the larger square to the smaller square, this time you have to be careful. 2 times what gives me 1? Well, the answer is 1/2. So the scale factor would be 1/2 if we were going from the large to the small square. It's going to be 2 if I'm going from the small to the large. So you have to be careful and see what they're asking on the homework questions. Now, I have a large triangle, oh my goodness, rectangle, hello, a large rectangle and a small rectangle. And we want to figure out what is the scale factor from the small rectangle to the large one. And so what I want to do first is I'm going to start with my small one and then look at my large one and see what are some corresponding sides. So I see that 10 corresponds with 25. And so I'm going to say 10 times what factor equals 25. Now that one's not as easy as the square. The square was just 1 times 2 is 2. So what I'm going to do down here is I'm going to write an equation. My small length of 10 times what scale factor is part of a multiplication problem. So 10 times what factor equals what? Equals 25. 10 times what factor equals 25? Well, let's go ahead and divide both sides by 10. We can do that algebraically. And my factor, well, 25 divided by 10, you can write it 2 ways. You can write it as 2.5, or you could simply write it as 2.5. Either way, your scale factor is 2.5 or 2.5. So 10 times 2.5 will tell me what the larger length is that corresponds to it. Now, if I take 4 and multiply it by 2.5, will I get 10? Well, to save you some time, I will tell you the answer is yes. And so the smaller length times a scale factor of 2.5 gives me the corresponding larger length. Okay, that is scale factor. What do I multiply my length by to get the other corresponding length? And let's go ahead to the other side and let's talk about scale factor in another way. Now, over here I have 2 cubes. This cube, all the dimensions are 1. Over here, this is a larger cube, all the dimensions are 3. So what's the scale factor from the larger cube dimensions to the larger cube dimensions? Well, 1 times 3 is 3. So my scale factor is 3. Now, we're going to use that information in order to figure out some interesting new things. All righty. Now, what is the perimeter? We're going to talk about 3 different things here. Okay, first of all, the perimeter of one of these squares. Well, each side is 1 unit, and 1 times 4, the perimeter is 4. For the large square over here, the perimeter is 3 is the length of each side. 3 times 4 is 12. Now, let's answer this question. How many times greater is the perimeter of the large square than the small square? In other words, 4 times what gives me 12? The answer is 3. Okay? How many times greater is the perimeter? And it is a 3. Now let's keep going, and then we're going to see something really cool. Now let's compare the areas. Let's just take the area of one face here. Well, 1 times 1, okay, this is a 1 times 1 square. The area is 1 square unit. Over here, let's take the area of this front square, this front face. 3 times 3 is 9. How many times greater is the area of the larger cube than the smaller cube? How many times greater? Well, 1 times 9 is 9. So it's 9 times greater. Now let's look at the volume. Well, the volume of this cube is 1 times 1 times 1 is 1. And the volume of this cube is 3 cubed is 27. And so, how many times greater is the volume of the larger cube? Well, it goes from 1 to 27. It is 27 times greater. Now, we didn't really have to do all of these calculations, even though they were rather simple, because what you can do, if you know the scale factor, okay, between two three-dimensional shapes or between two squares in this case, okay, you can simply take the scale factor and the perimeter, in this case the scale factor is 3, the perimeter will be the scale factor, 3 times greater. The area will be the scale factor squared, 9 times greater. And then we can take the scale factor to compare the volumes and cube it. Alrighty? So 3 cubed is 27. So all I need to know is the scale factor. Let's go ahead and draw one more cube. Let's do a cube that is let's do a 2 by 2 by 2 cube. 2 by 2 by 2. All right, so what's the scale factor from the smallest cube to the 2 by 2 by 2 cube? The scale factor, I'm going to put SF here, the scale factor is 2. So if I asked you, how many times greater is the perimeter of this square than the small square? It would be 2 times greater, okay? Match with the scale factor. Now, what about the area? Well, the area of this square would be 2 squared, or 4 times greater. I take the scale factor and square it to compare the areas. And for the volume is going to be 2 cubed, or 8 times greater. So 2 to the first, 2 squared, 2 cubed. 2 times greater for the perimeter, 4 times greater for the area, 8 times greater for the volume. Okay, so we can just take our scale factor and raise it to the first, second, and third power to compare perimeter, area, and volume. Now, let's go to number 21 and 22 on the homework for today. So number 21 is a review problem, but we really have to do this review problem first before we're going to do the number 22. So we want to solve for X and for Y. So let's just remember, these are similar triangles, and I didn't even mark this, but we have the angles are all the same. These are both 90. These match, 1 tick mark, and these match here. Okay, no tick mark there, but they do match because if two match, the third will always be also congruent. So these are similar, okay? They have the same proportion. So let's go ahead and solve for X first. We have to solve for X and for Y, and actually the dimensions here are in inches. Oh, I put that, they're in inches. So we're gonna go ahead. Let's look at solving for X first. Okay, let's go ahead and solve for X. Now, the first thing I want to do is look at my 2 triangles and let's find a corresponding pair of numbers that are made available to us. And so we have a 20 and a 50 here, a 20 and a 50. Let me bring this a little bit closer for you. There, okay, 20 and 50. Now, let's go ahead and write that proportion. 20 is to 50, and then we put an equal sign. Let's solve for X. As X is to what? What does X match up with? X matches up with 30. So 20 is to 50 as X is to 30. Notice I have the small triangle measurement in the numerator, the large triangle measurement in the denominator. Now let's go ahead and cross multiply here. So I've got 50 times X equals 20 times 30. Let's divide both sides by 50 and see what we're going to get here. Well, I'm going to go ahead and cancel out a 0 here and a 0 here. And I have X equals, now 30 divided by 5 is 6 over 1. And I have 6 times 2 left over. Well, 6 times 2 is 12. And so X is equal to 12. Don't forget your unit of measure, 12 inches. We've used a proportion to solve. Now let's solve for Y. Well, I'm going to go back and still use my same proportion. 20 is to 50. I always use what they give me to begin with. I could have now used, I know X is 12, I could have used 12 to 30, but what if I got the X wrong? Then I'm definitely going to get the Y wrong. So I always start and use the same 2 numbers that are given in the problem. Now 20 is to 50. Let's solve for y this time. And now I've got a 16 and a y. So which one goes in the numerator? I have to be careful here. Well, if I've got the 20 over the 50, small is to large, I've got to put my 16, goes with my small triangle. It also has to go in the numerator like the 20 did. Small is to large as small is to large because 16 corresponds to y. Now let's go ahead and cross multiply again. I've got 20y equals 50 times 16. Let's divide both sides by 20 and cancel out and solve for y. All righty, I'm going to cancel out my 0 in my 0 in my 50 and my 20. 16 over 2 cancels out to 8 over 1, and I've got 8 times 5, how nice, is 40. And I've got 40 inches for my value of y. And that is the answer to 21. That's our review problem. Now, let's look at 22. What is the scale factor? Ooh, the scale factor from the small to the large triangle. Okay, so let's use the 20 and the 50. A factor is something we multiply. So 20 times what factor will give me 50? 20 times what factor equals 50? Now let's write an equation for that. 20 times what factor equals 50? Let's divide both sides by 20 to isolate our f. We're solving for the factor. The factor is equal, let's cancel that. 5 halves is 2 1/2 or 2.5. My scale factor is 2.5. In other words, 20 times 2 1/2 or 2.5 should give me 50. Likewise, x is 12. 12 times 2.5 or 2 1/2 should give me 30. And 16 times 2.5 should give me 40. So there is how I find my scale factor. What am I multiplying 20 by to get the corresponding side of 50? Okay, now 2 things to talk about. First is our omissions. We've already done 21 and 22. We're also going to omit 1, 4, 7, 9, 18, and 20. 1, 4, 7, 9, 18, and 20. You do have Khan Academy, but I'm only going to give you 2 sets, and one has 4 questions and the other one has 7 questions. So 11 Khan Academy problems, and they will be due on Friday. I'm going to not have one due every night, so just pick a night that you don't have as much to do, and you can work. Both of these have to do with percents. Like I said, both of them are not due until Friday at midnight, or 11:59 p.m. to be exact. So that's it for today, scale and scale factor. Come and join us at the Zoom meetings at 1 and at 2 o'clock to get extra help. I'd love to see you. If you go back and look on the class wall for the password and for the ID to get into the meeting. I miss you, and I will see you again tomorrow. This homework set is going to be due tomorrow morning at 9. Please make sure you've gotten lesson 97 posted by 9 a.m. this morning. It's such a help to me if you have it posted so I don't have to track you down. All right, well, have a great day, and I will see you at the Zoom meeting, hopefully, or tomorrow morning. Bye-bye.